Hi everyone. This lesson is about adding and subtracting whole numbers, which you've been doing for quite some time. The only difference is that the numbers are getting larger. So our title is Adding and Subtracting Whole Numbers. Oops. Not sure what you saw there. Okay. An addend plus an addend equals a sum. For example, in 4th grade, you are responsible for knowing numbers up to the 100 millions place, specifically 999,999,999, which is just one number away from a billion. So let's use a large number, such as 483,765,096. And let's add to it 355,870,812. Notice how the commas have names. These commas are called thousands. These commas are called millions. We start in the ones place value and add. If we have more than 9, we have to go to the next place value because we have a base 10 number system that we're working with. Those of you who understand base 10 systems well, there are other kinds of systems. There are base 5 and base 2, but basically it just means that in a base 10 system you have 10 different numbers that could go into a spot before you have to move to the next place value. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those 10 numbers are used. Okay, so in our base 10 system, let's add. 6 plus 2 is 8. 9 plus 1 is 10. So in a base 10 system, I would put my 0 and then add my 1 to the next place value. 1 plus 8 is 9. Put your comma. 5 plus 0 is 5. 6 plus 7 is 13. So I place my 3 and then I add my 1 from the 13, or the 10 from the 13, to the next place value. 7 plus 1 is 8, and 8 plus 8 is 16. So I place my 6 and then I add the 10 from the 16, or the 1, the digit 1, to the next column. 3 plus 1 is 4. 4 plus 5 is 9. I don't have to carry anything because remember, it's a base 10 system. I don't have to carry until I get to 10. 8 plus 5 is 13. So I do have to carry and add 1 to the next column. 4 plus 1 is 5, plus 3 is 8. So our answer is 839,635,908. Remember, you do not say and anywhere in a whole number. The word and is reserved for the decimal point when you're calling the number. And if all of these numbers had a decimal point, this is where they would be. So everything we're working with right now is to the left of the decimal point. Okay? This is called addition. Add in plus add in equals sum, even if it's this way. You can stack them to add them, or you can write them out. With smaller numbers, we usually write them out horizontally. And I'll pause to let you take notes. To subtract, we start with the minuend. These may be new words for you, but the minuend is the top number. The subtrahend is the number that is being subtracted. Easy to remember, subtrahend, subtract. That's the number being subtracted. Notice how these two words are different and these two words for addition are the same. That's because these two numbers can commute. They have the commutative property. Doesn't matter which way you add them, they still add up to be the same. With subtraction, you cannot do that. You must have one number that is subtracted from the other. It doesn't work when you commute or change the numbers. The answer is called the difference because it's how different the two numbers are from each other. So minuend minus subtrahend equals difference, even if you, with smaller numbers, are writing it this way. So let's use an example of the numbers above. This time we're subtracting. So if I take the total, which was 839,635,908, and I subtract either one of these numbers, I'll just pick this one. Let's subtract 483,765,096. I should get this answer. We'll see if I'm right. This is a part, this is a part, they add up to be a whole. This is the whole, you're taking away one of the parts, so we should end up with the other part. Let's see if we do. 8 minus 6 is 2. 0 minus 9. We can't take 9 away from 0. So we have to borrow some extra numbers here. I'm going to take this 9 and make it an 8. And then I'm going to create the number 10 here. I put the 1 and make this a 10. Now I can subtract. 10 minus 9 is 1. Now this is not really 10 minus 9. This is 100 minus 90 equals 10. Because look at that place value. This 1 is in the tens place. This is really 100 minus 90 equal 10. It's very important for you to understand that. But while we're subtracting, we just pretend like they're single digit numbers. 8 minus 0 is 8. But this is really 800 minus 0, which is still 800. And it's in the 800 place like it's supposed to be. 5,000 minus 5,000 is 0. 30,000 minus 60,000, well, that makes it a little hard. Let's just pretend like it's 3 minus 6. I still can't do that. So I'm going to borrow next door and make this one less. And I'm going to make this number a 13. Now I can subtract. 13 minus 6 equals 7. Okay, again, 5 minus 7. I can't do that. So I need to go next door and borrow and make the 9 and 8. And then I need to add the 1 here to make this a 15. 15 minus 7 is 8. 8 minus 3 is 5. 3 minus 8 can't be done, so I must borrow here. I'll make this a 7, and I'll make this a 13. 13 minus 8 is 5. 7 minus 4 is 3. Now that's really 700 million minus 400 million. But it's easy just to think 7 minus 4 is 3. 700 million minus 400 million is 300 million, and that's exactly where the 3 is in the place value of the answer. Did I get the other part? Yes, I did. 355,870,812. I'll pause and let you finish note. Okay, we're going to talk about the term inverse operation. Inverse operations. Okay? The minuend minus the subtrahend equals the difference. Okay? The sum, which is what the minuend is, equals the addend, which is the subtrahend, plus the addend, which is your difference. See how they relate to each other? In the addition, your total was your sum, and it became the minuend when you were subtracting. So they represent the same number. These are called inverse operations because they are the opposite. For example, 10 minus 7 equals 3. And 10, the sum, is equal to the addend plus the addend. These are inverse operations. Let's practice. $873,207,658 plus 126,792,342. 8 plus 2 is 10. I put my 0 and add my 1 to the next place value because I can't put a 10 in a single space. So I have to move the 1 over. 5 plus 1 is 6. 6 plus 4 is 10. I put my 0 and again I place my 1. 6 plus 1 is 7. 7 plus 3 is 10. Again, I put my 0 and place my 1 or carry it. 7 plus 1 is 8. 8 plus 2 is 10. Again, I place my 0 and I carry my 1. 1 plus 0 is 1. 1 plus 9 is 10. Again, I place my 0 and carry my 1. 2 plus 1 is 3. 3 plus 7 is 10. Again, I place my 0 and carry my 1. See the pattern here? 3 plus 1 is 4. 4 plus 6 is 10. I place my 0 and carry my 1. 7 plus 1 is 8. 8 plus 2 is 10. I place my 0, carry over my 1. 8 plus 1 is 9. And 9 plus 1 is 10. Since I don't have any other place values to add, I put my 0, and then I can place my 1 here, and this is 1 billion. This is the hundreds, the thousands, the millions, and now we've started the billions. So this comma is named billion. Now we're not responsible for numbers larger than a billion, but we are responsible for all numbers up to 999,999,999 plus 1 equals a billion. Okay, let's do another example. 973,624,079 minus 911,463,163. 9 minus 3 is 6. 7 minus 6 is 1. 0 minus 1 can't be done, so I must borrow. Make this a 3 and make this a 10. 10 minus 1 is 9. 3 minus 3 is 0. Actually, this is 3,000 minus 3,000 is 0 thousandths. But it's easier just to look at it and say 3 minus 3 is 0. 2 minus 6 can't be done, so we borrow and make this a 5. And we make this a 12. 12 minus 6 is 6. 5 minus 4 is 1. That's really 500,000 minus 400,000 is 100,000. And as you can see, the 1 is in the hundred thousands place. 3 minus 1 is 2. 7 minus 1 is 6. And 9 minus 9 is 0. So I can put the 0, but we don't have to. So I'm going to erase it if I can get the pen to work. Okay? And we'll just leave it as this. Okay? So minuend minus subtrahend equals difference. Addend plus addend equals sum. This, students, is how you add properly and how you subtract properly to get correct answers in 4th grade math.